In this video, we're going to look at general thoughts about electrochemistry. What is electrochemistry, and how can you tell if a chemical reaction is an electrochemical reaction? And so to start, we'll define electrochemistry by saying that this is going to be a reaction where there is an exchange of electrons between two things. So exchange of electrons. And these electrons are going to go from one element to another element. So, so a very simple example would be something like where magnesium solid reacts with HCl, that's aqueous, and in this reaction what's going to happen is you're going to get magnesium chloride, MgCl2, and that's going to be aqueous, and you're going to get H2. Now, that's a gas. So how can you tell if this is an electrochemical reaction? I just told you it was, but how do you know? So what you need to do is you need to look at the oxidation number of each element involved and decide if the element is gaining or losing electrons. Some chemical reactions do not involve the gain or loss of electrons. Those are not electrochemical reactions. Only the reactions where electrons are moved around between elements are considered electrochemical reactions. So let's look at magnesium here. So by definition, magnesium as a solid has an oxidation number. So let's write down oxidation number here. And these are going to be, this is going to be 0 for magnesium. If we look at hydrogen here, it's with a non-metal, so hydrogen is going to be +1. That means that chlorine is going to be -1. On the right-hand side of the equation, magnesium here is with chlorine. This is going to be a magnesium +2. And chlorine is still a -1. And then hydrogen over here, because this is the natural form of hydrogen, it's hydrogen gas, hydrogen is now going to be 0. So if we look at this now and decide what has happened in this reaction. So magnesium is going to go from 0 to +2. So is that a gain or loss of electrons? Well, since the charge is getting more positive, this is going to be a loss of 2 electrons. So this is going to be, as you know, you have oil rig, right? Oil rig indicates oxidation is losing. So oxidation is losing. And of course, we're talking about electrons here. And then reduction is gaining. So that's your way to remember what oxidation and reduction are. And so in this case, magnesium is losing electrons, so this is oxidation. Okay, so this is definitely an electrochemical reaction because magnesium has lost electrons. That also means that something else must have gained electrons. And so if we look at these other elements here, we've got hydrogen starting out at +1, chlorine at -1. On the right-hand side of the equation, though, chlorine is still at -1, which means that chlorine didn't change in this reaction. So chlorine is not the element that is accepting the electrons because magnesium lost them, so something else has to be accepting them. Hydrogen actually is going to be what is accepting the electrons. I should balance my equation with a 2 there. But so hydrogen is actually going to be accepting. So hydrogen is going to go from +1 to 0. And so that is a gain. Now, notice that the charge went down. So electrons are negative, so when you gain a negative thing, your charge will become less positive. So this is going to be a gain of 1 electron, but there are 2 hydrogens. So this is going to be a gain of 1 electron for each hydrogen. All right, so that is reduction. So most of this is not new. This is going to be something that's going to be covered in Gen Chem 1, but it's good foundation for electrochemistry as we're going to learn it here in Chemistry 2. So to review, we have common terms: oxidation, reduction. We need to be able to look at a reaction and determine if it's an oxidation-reduction reaction or not. In this case, we can see that it is. We need to be able to figure out what is being oxidized and what is being reduced. So those are some things from Gen Chem 1 that are really useful. Now, we're going to take this a step further, and also from Chem 1, we're going to review how to write down half reactions for oxidation and reduction. Okay, so here's a summary from what we had from before, where we had determined that for this reaction, magnesium is losing electrons, hydrogen is gaining electrons. So what we want to do now is write down a half reaction. Now, half reactions are also something that was covered in Chem 1, but they're so important for Chem 2 in understanding the galvanic cells that we're going to talk about in future videos, that it's just really important to review that and emphasize their importance. So basically what you want to do here is you just want to write down what's going on with the magnesium for the oxidation half reaction. Okay, so for the oxidation one, we're just going to write down what magnesium does. So in this case, magnesium is going to go from a solid to a magnesium 2+. All right, so that is going to be, now that's going to be the oxidation half reaction. We're going to add electrons in there, and we know that since it lost 2 electrons, we're going to add those in as products. So we're going to put magnesium solid goes to magnesium 2+ plus 2 electrons. And so that is going to be the oxidation half reaction. Now, for the reduction half reaction, we're going to write down everything that's involved with hydrogen. So we determined that hydrogen was reduced. So up here, we're going to write down everything that's involved with hydrogen. So that includes our HCl. So we're going to put our 2 HCl here. That's aqueous. And then we're going to understand that the hydrogen is the thing that is gaining the electrons. So it's gaining 2 electrons. So we're going to add 2 electrons here. And then we're going to draw the arrow and put down our H2 on the right-hand side. So that is what's going on with the oxidation and reduction half reactions. Now, why is this important to review for Chemistry 2? Well, what you can think of in terms of a battery or an electrochemical cell is you can think about electrons that are going to be moving from one element to another. And when elements lose and gain electrons, they're going to do it directly in a solution, right? So if you have a beaker or a jar of solution that has 2 elements in it, and there's an oxidation reduction reaction that's going to happen there, then the transfer of electrons is going to be direct, sort of like handing an envelope from one person to another, right? If you want to just give someone an envelope, you just walk up to them and you give that to them. So that is a transfer, direct transfer. What we do with electrochemistry a lot of times, especially when we're talking about cells, like batteries basically, is we're going to separate these 2 half reactions, physically separate them. We're going to put them in separate beakers. So we're going to separate, for example, the magnesium and the HCl, and we're going to put those things in separate beakers so that when the exchange happens, it has to go through a wire. And so we're going to add a wire into the whole thing so that the electrons have a way to get from the oxidation site of oxidation to the site of reduction. So that is a really important thing to understand in terms of just understanding half reactions. Really sets the stage for being able to understand how the electrochemical cell functions.